Okay, so we're going to do exponential and log definite integrals. Okay, so it says find the value of each. So looking at number 1, we're going to have to do u substitution here to evaluate this integral. So with this, I'm going to set the exponent equal to u and do the derivative. Coming back to my integral, I'm going to leave this e to the x cubed inside the integral. I'm going to move the 2x squared out front and divide by du. This simplifies down to 2/3, and then I'm subbing in u. When I take the antiderivative here, I get e to the u, and I normally put plus c, but since it's a definite integral, we just use the long bar to the right and put 0 to 2. I am going to I need to then plug in what we said u was, which is x cubed. Now I'm going to evaluate this expression for 2, and then evaluate it for 0 and subtract those two. So I'm going to plug in 2. I'm going to plug in 0. So here that becomes, this is an 8, so 2/3 e to the 8th, and we're going to leave it just like that. And then this becomes e to the 0, which is just anything to the 0 power is 1. So this is 1 times 2/3 is just 2/3. So we leave it just like this. Okay, so with this, I'm going to set the denominator as u. Take the derivative, which is 2x. We move the numerator in front of the integral. So this is what I'm left with inside. I divide by du. So this part simplifies to 1. I'm going to sub in u for the denominator. When I go to evaluate this, it's just going to be ln u. Again, you put plus c, but since it's a definite integral, we can leave that off. Sub back in 6 plus x squared, and then we're going to evaluate it. So we have ln 6 plus 3 squared minus ln 6 plus 1 squared. Okay, this is going to become 3 squared is 9, plus 6 is 15. This is going to become ln 7. Okay, so what we need to remember from our log properties is if I have 2 logs with the same base that I'm subtracting, so these are both base e, then what I can do is I can condense it to a single log and divide what is inside the log. So that's what I'm going to do with this. I'm just going to say ln 15 divided by 7 because this is subtraction. Okay. So another example with the fraction. So for this one, I'm going to set the denominator equal to u and do the derivative. So I get 2x. I'm going to move this numerator in front of the integral and divide by du. I leave this 1 over x squared plus 4 inside the integral. This simplifies to 4, and then I sub in u. Evaluating this, I get 4 ln u from 0 to 4. Excuse me. Then I'm going to sub back in that for u. Okay, and let's evaluate this. So I'm first going to plug in 4 minus, and I'm plugging in 0. This is going to become 16 plus 4 is going to be 20 minus 4 ln, this is going to become 4. So I'm going to GCF out the 4. And then again here, we're going to be doing, since that's subtraction, I can condense this to a single log by dividing 20 by 4, because we just take what's inside the logs and divide them. And that's 4 ln 5. Okay. Another fraction one. So I'm going to set this denominator equal to u. Do the derivative. GCF out that 2, or take that 2 in front of the integral. Divide by du. So this simplifies to 2. And I have 7u here. When I go to evaluate this, I get ln u from 0 to 4. Sub back in x plus 3 for u. Okay, evaluating this, I plug in 4 and then minus plugging in 0 to that. So this is 2 ln 7 minus 2 ln 3. Taking the 2 out, I'm left with ln 7 minus ln 3, which we can write as ln 7/3 with that 2 out front. Okay, let's try one more. Another exponent one. Okay, or with an e. So again, I take the exponent and I set that equal to u. When I take the derivative, that's 3x squared. This gets moved out front and I divide it by du. And I'm just left with e to the x cubed. This simplifies to 1/3. And then I write my sub in my u here. When I do the antiderivative, I get e to the u from -2 to 0. Of course, I sub back in x cubed there. Okay, I'm going to plug in 0 here. And then I'm going to plug in -2. So this just becomes 1, which means this is just 1/3 minus 1/3. This is going to be e to the -8. And we can push that negative exponent to the denominator. So it's going to be with that 3. And there's our final answer.